So in this question here, we want to try and estimate the distance travelled by a jet in takeoff after 25 seconds. Now we've got a table of values here of the speed of the jet on 5-second intervals. So they're all here calculated in meters per second. And what I've done is I've drawn a little graph and I've plotted each of the speeds of this jet at each of these 5-second intervals on this particular graph. Now we need to estimate the distance, so how are we going to do that? Because we don't actually have a formula or anything, we just have these values. Now what we do know is that if you have a graph with speed and time, the distance under the graph is the actual distance travelled by the object in question. So what we can do here, first of all, is we can just try and join up all these dots and make a curve. So if I just go along like this, graph of the trajectory of the speed of the jet will be looking like this. Now we don't know the equation for that graph, so the area underneath here we're not going to know, so we're going to need some form of estimation. So what we can do is we can break it up into its 5-second intervals and use something called the Trapezium Rule. So the Trapezium Rule, so what that will involve is breaking these up into its 5-second little marks. So if I do that, just roughly like that, so we can see what's going on, and then we finally estimate the area of each one of these and add them up, and that will give us an estimation of the distance travelled. Now the trapezium, if I just take this one out of here, what I will have to do, because this line here will be a curve, I will have to somehow straight line each one of these. So and so on, and then that way then if I've got a straight edge I can use the formula for a trapezium to calculate. So for example, if I take this one here and pull it out, I've got 2 on this side, be 5 along here, this height will be 5 as well because it's indicated by after 5 seconds it's 5 meters per second, so this will be 5, and then we'll have a straight line there. So therefore the area of this trapezium will be 2 plus 5 divided by 2 and then multiplied by this 5. And then we can do that for each one of these. So let's do that. So our area equals, so the first one is 5 times, and let's put a nice big square bracket and let's see if we can fit all of these in. So 2 plus 5 over 2, we've already done the first one. Then to add the second one, we've got these values in our table. So the speed is 5 and then to 10. So we add 5 plus 10 and divide that by 2. We've already got our multiple of 5 because all of these are 5-second intervals. So the next one is 10 to 18. And then half that. Next one is 18 to 28. And the last one is 28 to 42. And just managed to squeeze all of those in. Okay, now need to try and calculate what this, or try and simplify it. So we keep our multiple of 5. Now we notice here everybody is divided by 2. So we can bring that out and bring 5 over 2 as our multiple. Now you'll see here we've got 2 plus 5 plus 5 plus 10 plus 10. So all the middle numbers, except for the outer 2, are twice. So what I can redo is rewrite this as 2 plus, and then 2 times 5. And I've also got 2 times 10. So I can just add these numbers up. And 18. I've got 2 28s. And I've only got 142. So that would simplify that calculation up. Okay, so now it's just some numbers in there. Let's see if we can calculate what we've got. So I've got 5 over 2. So 28 plus 18 is 46. 56, 61. Times 2 is 122. So I've got 2 plus 122 plus 42. And this will make 122, 164, 166. So that makes 166. So I've got 5 over 2 times 166. Okay, multiply that up. 2 times 266, I can factor that down, 83. 583 is 415. Now 415, my units for my distance are going to be in meters because my time is in seconds and my speed is meters per second, so it's 415 meters. So that'll be the answer for my distance travelled as an estimation. Now as my lines are going slightly over the curve, this would be an overestimation of what we've calculated. So this is an overestimate. So our actual distance will probably be slightly less than 415 meters. But that's our approximation using the information that we've been given. Okay.